Okay. So the impedance. Okay, and please make sure that the reference impedance is 50, because if it is not 50, then the component value is going to differ. So for that, you can use this cursor window. So either you can go into the setting and you can check it, or just place the cursor at the center of the Smith chart. So it's 50.4. Okay, so it's 50. Okay. Next is the reference impedance. Reference impedance, if you want, you can feed. Otherwise, it's not required, because reference we are having it is 50 and it will be at the center of the Smith chart. Okay. So here, data points. Now 50, which is at the center, and 25 plus J50, there is a load. Okay. Now we'll see the different solutions, possible solutions for the given problem. Okay, so for that, see how much mismatch is there, that you can see it. So if the cursor is placed at the load, so you can see that the VSWR is 4. In worst case, it should be what? 2. Ideally, it should be 1, but worst case 2. Reflection coefficient 0 or 0.3. Ideally 0, and worst case 0.3. So you can say it's 0.618. Reflection coefficient is very large. Okay, that's why we need this one. Okay, so let's see. So our goal is what? To move to the center of the Smith chart. The reason already we have discussed that if you place the cursor at the center, so you can see that the VSWR is 1, reflection coefficient that also is 0. Okay. And if you are placing cursor here, so VSWR is around 4 and reflection coefficient is 0.6. So we have to convert this figure into this desired one, the ideal one. Okay. So for that, we have to add components. So we can refer this circuitry. This is the load and the reference impedance 50 ohm. Okay. So let's start. So now, as your goal is what? To move to the center of the Smith chart. So you can move on this red circle, and from there you can move to the center of the Smith chart with the help of this dark blue circle. So here you can see that this dark blue circle and this dark red circle, these are the only two circles which passes through the center of the Smith chart. Reason? Because the real part for the red circle is 50, okay, and for imaginary this blue circle, it is 1 by 50, because it is admittance chart. Blue circle or blue part of the chart represents admittance chart. Okay, so we have to talk in terms of conductance and susceptance, right? So this blue circle which is passing through the center of the Smith chart, it is just the inverse of this red circle. Okay, and these two circles are the only circle which passes through the center of the Smith chart. That's why what you have to do, wherever you are currently present, your goal is to somehow reach to any of these two circles. Once you have reached to this circle, now those circles will take you to the center of the Smith chart. Okay, so one obvious way is the step is what? You can move on along this red circle. Okay, because this red circle intersects this blue circle, so you can reach to this point. Now, since you are, in order to move to this point, you have to move in anti-clockwise direction, and that too on the Z chart. Okay, so you need to connect one capacitor in series. So you have to verify your answers. Okay, so one 6.3 picofarad capacitor is required. So just cross check it. It should be near to this only. Now once you have reached to onto this blue circle, now this blue circle is what? Passing through the center of the Smith chart. So what you can do now, you can take the help of another component. and you can reach to the center of the Smith chart. Now this time you are moving in clockwise direction and Y chart. So once again C is required, but this time in shunt. So you can see that the two capacitors are required to transform this 25 plus J50 ohm into what 50 ohm at 1 gigahertz. So if you change the frequency, then this matching network will not be able to transform this 25 plus J50 into what 50 ohm. Okay, so it is going to happen only at this 1 gigahertz. So if you are changing the frequency, so little mismatch will arise, and this mismatch is going to increase if the frequency deviates more and more from this 1 gigahertz. So just check your answer from the earlier session. Okay. Now the second solution. Second solution, you can move from here and you can land on the lower cross section point, intersection point, and from there once again you can move to the center of the Smith chart. Okay, so you can follow this path, a larger value of C and then one inductor. So let's see, you can go like this. So still it is capacitor, but now you can see that the capacitance, earlier it was somewhere around 6 picofarad, now it is 2.1 picofarad. Well, right. So lower value of capacitance, right? Because you have to change the inductive reactance into what capacitive one. So you want to have a larger capacitive reactance. So that can be achieved only at smaller value of capacitance. Then only the reactance will be larger. Okay, now we have to move from from this intersection point to the center of the Smith chart. So for that, you need to work on shunt inductor, because you're now this time you're moving in anti-clockwise direction and Y chart. So shunt inductor is required. Okay, so here you can see that one capacitor in series, then one inductor in shunt is required. But in an earlier case, it was one series capacitor and one shunt capacitor. So both the components can have similar nature. Either both can be inductive or capacitive, or they can be different. If any queries there, you can raise. Otherwise, we can go for the other possible solutions. Now, the alternate way is what? We have been taking what? The help of blue circle to reach to the center of the Smith chart. Okay. Now, in the other two cases, we can take the help of red circles to reach to the center of the Smith chart. Okay. So for that, now what you have to do, since your load is what present. Load is present here. Okay. So what you have to do, you have to move from, or you have to jump from this circle to this dark red circle. Okay. So that can be done with the help of what? The blue circle.
There is a request that in the theory, what we did, the same path with the upper part of the blue circle, 1 plus JB circle. So if you will take first, so it will be better. On the left hand side only, but the upper part of the 1 plus JB circle. Two capacitors part.
So it was this, no?
This one, yes. then
Yes.
the other
So I asked them to
two
verify the answers. Hello.
yes, sir, the same case. So this one we can verify with the theory. Now C1, what we got here, 3.1 picofarad. So C1, so the circuit, series, yes. Uh, the C1 we got here 6.5 picofarad. In the theory, we got 6.37 picofarad. So the agreement is there. This is what C2. C2 is near, that is C2 is which is in parallel. So parallel capacitor here in the experiment we got 3.1 picofarad, and in the theory we got 3.18 picofarad. So there is an agreement. Yes, sir. This is verified. If there is any question by the student, they can ask. So this is what we did in the on the Smith chart. This is what the answer you can verify on the Smith chart and this. So all the four cases that you have to do. Sir, you can continue.
Okay, sir. Okay. So what I said that the way we took the help of what this blue circle, there is a final components were this in shunt. Okay. So but when you are taking the help of what this red circle, the final component is going to be in series. Okay. And the first component it is going to be in shunt. Just the reverse of that. Okay. So let's see. Now, as I said, that you have to move somehow. You have to what you have to move from this point, and you have to reach to the circle. So that can be done only with blue circles. Okay, means you have to move on the blue circle. So here you can see that this load is located in such a location that no blue circle is passing through that. But of course, there has to be a blue circle which will pass through this load and it will intersect this dark red circle. Okay, like this blue circle. Okay, so but we have to assume that there is some circle which is passing through this load and it is intersecting this red circle also. Okay, so now we are moving on the blue circle, and in order to reach from this point to this point, you have to move in clockwise direction, but admittance chart. Okay, our conductance circle you can say. So this time you need to work with what inductor, that too in shunt. Sorry, it's a capacitor. Okay, because going downside. So earlier, if you remember, it was a capacitor only, but in shunt. So sorry, it was in series. This time it is in shunt. Okay, so mesh to this circle. Okay. So one capacitor of 1 picofarad. So earlier it was 6.2, but it was in series. Now this time it is in shunt. Okay. Now from here you can go to the center of the Smith chart. Now for to the center of the Smith chart, you can take the help of this dark red circle. Now there is part of what? Impedance chart. So this time the component will be added in series. Now we are going downside. So capacitor is required. Series C. Can see two capacitors once again, but the first capacitor is in shunt now. Earlier it was in series, and the second C was in shunt. So here the second C, that is capacitor, is in series. Okay. So only the configuration of the component has got changed from series to shunt and shunt to series. Otherwise, both are capacitive in nature. So this is the third solution for the same problem. If any queries there, you can ask. calculation, then you can cross check your calculation.
So we need to perform for 4 cases, right?
I think sir has told to perform all the 4 cases on V Smith, and
no, sir.
one of those cases
all all 4 cases on Smith chart as well as V Smith.
Okay, all 4 cases.
Okay, sir.
Okay. Okay, now we will go for the 4th case. So in 4th case, what you can do now, you can alter the nature of what final component. Like the final component, it depends on what your movement on this dark blue circle, sorry, the dark red circle. So earlier you were moving in anti-clockwise direction. If you move in the clockwise direction, the nature of component is going to change. Okay. So once again, shunt C. Okay. This time we have to reach to the lower intersection point. So here, right now you can see that you have landed on the red circle only, but this time on the lower half part. So once again, capacitor, the value is 4.1. Okay. Now, in order to reach to the center of the Smith chart, you have to move upward. Okay. So moving upward means here you have to move in clockwise direction. Clockwise direction and impedance chart. So series inductor is required. Right. So now you can see that this time the second component is which is in series is inductor. Earlier it was capacitor. So first was shunt capacitor. Here also first component is shunt capacitor. But the second component, earlier it was capacitor. This time it is inductor. Okay. So if any further queries there, you can ask. Okay. If you don't have any query, then I will ask. So is it possible for to guess how many components are involved in the design of the circuit just by looking at the Smith chart? If you have provided any solution using lump component under impedance transformation technique only, so can you guess how many components are will be needed in actual for the impedance transformation?
Sir, I think if we have this visor chart, then by looking this, we can tell that what will be the number of components.
How you are going to decide?
So, like in this question, we have chosen the path. So by choosing the path, we can decide the number of components.
Number of paths, distinct path means number of path means here what? I see you will be moving on this conductance circle and this resistance circle, right? So if you are moving on conductance circle and it's a one continuous path like here, you are starting from here and you are landing here. So it is one path. Why one path? Because now the next movement on the Smith chart is going to change. It is from here to here. Okay, so that's why I'm saying that these are the two different paths, and the circles are also different. This is conductance circle and this is the resistance circle. So these number of paths actually tells you how many components are required. So here one path, one component, second path, second components. So if there are three, you are choosing three different paths, then three components are required. And of course, what we are saying, it's a pure theoretical thing. Because see, here is said that 4.1 picofarad. So if the 4.1 picofarad is not existing in the market, then you have to go for a little different solution. So the real world and the theoretical world. Theoretical means you can have any figure on paper. No need to worry. But practical world means that that component should be there in the existence. Then only you can implement that circuit. Otherwise, it is not possible. So if you have any query, you can ask. Okay, so I think I can ask one more question. Impedance. If suppose I have only reactance, okay, let us consider this here only. Here it's 25 plus J50. Right? So if suppose I have to transform only 25 ohm into what 50 ohm. So do I need